In 1859, an astronomer named Edward Carrington became the first human to observe a solar flare. A few hours later, a particularly strong storm of particles from the sun struck Earth, destroying telegraph systems and displaying the northern lights across the night sky as far south as Cuba. We call these large solar storms Carrington events, but solar flares are pretty common. Large flares happen about once a day. Then why aren't our electronics constantly getting fried? The answer has to do with two things. One, the magnetic field of the Earth, and two, that the particles coming from the sun are charged. The magnetic force only acts on charged particles, and it bends those particles in circular arcs. If the Earth did not have a magnetic field, or if these particles were not charged, then the particles ejected from the sun, known as the solar wind, would slam into the Earth at high energies. Fortunately, the molten iron core of the Earth turns it into a giant bar magnet, which safely deflects charged particles away from the Earth. However, for solar flares as powerful as the one Carrington observed, the Earth's magnetic field isn't strong enough to completely shield us. Though because the Earth is so far away from the sun, and because the jet of particles released during a solar flare is pretty tightly packed, then these particles tend to mostly miss us. What exactly is a solar flare? Well, basically it's a giant explosion in the sun's atmosphere. In a few minutes, a typical solar flare will release 1,000 billion times more energy than the atomic bomb dropped on Hiroshima. Solar flares are so powerful that they will often eject a chunk of mass from the sun into space, creating glowing loops of plasma like this one, which flow along the magnetic field lines. Solar flares convert the sun's magnetic energy into particle thermal energy in a process known as magnetic reconnection. Magnetic reconnection in the sun starts with magnetic fields pointing in opposite directions. They move towards each other, and as they meet, they are reconnected from nearly straight field lines into highly bent magnetic field lines, hence the name magnetic reconnection. And kind of like how a bent trampoline releases energy by straightening out, these bent magnetic field lines try to become straight by rushing apart, dragging plasma with them, which creates jets of high energy particles. This same reconnection process which drives solar flares also creates the northern lights. Reconnection between the Earth's and Sun's magnetic fields shoots particles from the solar wind along the Earth's magnetic field lines towards the north and south poles, where they crash into the atmosphere, sending electrons to higher energy levels. As the electrons drop down in energy, they release photons of light, creating displays like this one.